Welcome. If you heard James, she said, "Oh my God," because we doing these intros, baby. You know me, I'm cringy. I'm bored and I gotta make these fun somehow. We're reviewing for MCAS. So that means we're gonna do operations with rational numbers. We're gonna get in it. We're in this YouTube video. Y'all are hooked. Y'all know the vibes. Let's go. Welcome y'all to the start of our review. As you guys can see, we're going to start off with absolute value. So the rule we learned in the beginning of the year of absolute value is the absolute value of a number is the distance that number is from 0 on a number line. And so absolute value is the absolute value of a number is the distance that number is from 0 on a number line, which means what we need to know is that distance is always positive. And so that's why our numbers just end up becoming positive. So these bars here, these bars mean absolute value. So this is the absolute value symbol. And so the absolute value of -4, well, if I see -4 on a number line, -4 is 1, 2, 3, 4. 4 units away from 0. And so since -4 is 4 units away from 0, the absolute value is just +4. That's why negative numbers become positive. If I want to know the absolute value of +4, well, that's just +4 because it's 1, 2, 3, 4 units away. So let's do the expression absolute value of -18 minus -15. This is kind of a glimpse of what we're about to do next, but this is review, so I can assume that we already know this. So subtracting a negative is the same as what? Hopefully you just thought in your head that subtracting a negative is the same as adding a positive. So I can rewrite this as -18 plus 15. And so this is the absolute value of -18 plus 15. And so -18 plus 15 ends up giving us -3, which means the absolute value of -3 is the distance -3 is away from 0, which is just +3. And so we get the absolute value of this expression just to be +3. Well, what about the absolute value of -9 minus the absolute value of 5? Well, the absolute value of -9 is just 9 minus the absolute value of 5, which is just 5. And then this is just 9 minus 5, which is 4. And so that means the absolute value of -9 minus the absolute value of 5 is welcome. Starting the second part of our problem, we have positive and negative rules with the 4 operations. So to start off, we're going to do addition and subtraction rules with positive and negative numbers. So we said this all year long. Subtracting a positive is the same as, well, subtracting a positive is the same as adding a negative. And so that's our example here, right? We have 3 minus 8, and so that is subtracting a positive, which is the same as adding a negative. So I could rewrite this as 3 plus -8. And so we can see we went from subtracting a positive to adding a negative. Now, to speed up the process, I already created the counters here. As you know, the hollow ones is positive, while the colored ones in is negative. And so what we remember about addition and subtraction is that the positive and negatives end up canceling out. And so we can cancel these, right? Because those cancel, these cancel, and I'm left with 1, 2, 3, 4, 5. I'm left with -5 counters. And so moving on to our next problem, right, we got 3 plus -8 is equal to -5. Here we have subtracting a negative is the same as, well, subtracting a negative is the same as, we should say adding a positive. So subtracting a negative is the same as adding a positive. And so instead of doing -5 minus -3, I can rewrite this as -5 plus 3. And so I get adding a positive, right? Subtracting a negative is the same as adding a positive. You want to make sure to change from subtraction to addition, but also make your negative number into a positive. And so but at this point, we probably already know what this is, but I want to show you guys how to also use the number line to model this. So you always want to start at your origin, and then we go to our first number, which is just -5. So I go all the way to -5, and so I'm at -5. And now I want to go on top of -5 and I want to add 3. And what we need to remember is that in order to add a positive, you're going towards the right. And so that tells us that we go 1, 2, 3. And so we went to the right 3 units, which tells us that our answer is just -2. And so that means -5 plus 3 is just equal to -2. And so what we end up doing is, right, we added two numbers with opposite signs. We did that both up here, right? 3 plus -8 has opposite signs because 3 is positive, 8 is negative. Here, 5 is negative and 3 is positive. So the rule when adding two numbers with opposite signs is you want to make sure to treat like subtraction. But the sign of your answer depends on the number with the largest absolute value. And so when we did 3 plus -8, -8 has a larger absolute value than 3, which resulted in our sum being negative. And so -8 plus 3 is -5 because -8 has a larger absolute value, which means our answer will be negative. Here we had -5 plus 3. So what that means is, right, -5 is further away from 0 than 3. So that means -5 has a larger absolute value, which means our sum will be negative. Let's say this was +5 plus -3. +5 would have a larger absolute value, so our answer would have been positive. All right, well, what about the rule of adding two numbers with the same sign? Well, when we add two numbers with the same sign, we want to add like normal, but keep the same sign as our two numbers. And so when you're adding two with the same sign, you want to make sure to keep. So we just talked about adding and subtracting. Now we're going to get right into multiplication and division with positive and negative numbers. And so for multiplication, a positive times a positive, we learned was just a positive. But we also learned is that a negative times a negative is a positive. And then when we multiply different signs, so a positive times a negative, we were told that it was a negative. And then a negative times a positive is also a negative. And so for our division rules, they actually stay the same. So positive divided by a positive is a positive. A negative divided by a negative is also a positive. and then a positive divided by a negative is a negative, and then a negative divided by a positive is also a negative. And so that leads us to our rules. Rule number 1 is multiplying or dividing two numbers with the same signs results in a positive. And so if you're multiplying or dividing two of the same sides, your answer are going to be positive. So if they have the same sign, the quotient or the product will be positive. Well, what about if you're multiplying two numbers with opposite signs? So a positive divided by a negative, or a negative, in this case, times a positive, you'd get a negative. Welcome to the last part of our direct instruction, which kind of brings all our rules together. As you can see some writing down already. We did that just to save some time. So let's start off. So here we have -1 2/5 minus -2 5/10. So this is why we say -2 5/10 by the place value, because -2 5/10 as a fraction is literally just -2 5/10, right? The -2 5/10 terminates in the tens place, so the denominator is 10. So then we carry everything else down, minus -2/5. And so what we were told is that subtracting a negative is the same as adding a positive. So I can rewrite this as -1 2/5 plus 2 5/10. But we have two fractions that have unlike denominators, and so you need to figure out the like denominator between 5 and 10. And the strategy that you can use if you can't see it right away is by making our chart, and then you skip count until you get the same denominator. So it's 5, 10, and then 10. And so our common denominator is just 10. And so what I like to do is I like to rewrite it as -1, and I like to bring down the common denominator right away. This assures I don't mess up. And so on our first one, we know we need to multiply 5 by 2 to get to 10. That means we need to multiply our numerator by 2 as well, and we get -1 4/10 plus 2, and then this is just staying 5/10. And so what we end up needing doing is we need to add our whole numbers first. And so what we end up getting is -1 plus 2 ends up giving us 1. And then -4 plus 5 ends up giving us 1/10. So that tells us our answer is just 1 1/10. And so again, what we need to remember is that our 4 here is negative, and so it's really 5 plus -4, which is why we got +1, and then 2 plus -1 is +1 as well. Going on to part B, we have a complex fraction here. That just means a fraction over a fraction. No need to worry, it just means division. What you need to remember is that your numerator is your dividend and your denominator is your divisor. So you can rewrite it as 1 3/4 divided by -8 1/2. And so this is a positive divided by a negative. So you already know your final answer is going to be negative, but you're dividing two mixed numbers. And what you need to do when you're dividing a mixed number is you need to make it into an improper fraction. So we do around the world. 4 times 1 is 4. Add that to our numerator 3, and we end up getting 15 over 4. Oh my gosh, I messed up. So 4 times 1 is 4, and then we add 4 to 3. And so this is just 7 over 4. Divided by 2 times 8 is 16, plus 1 is 7. So this is -17 over 2. And we know that we need to take the multiplicative inverse when we're dividing by a fraction. And that's just a fancy way to say we keep our dividend. We change from division to multiplication. And then we take the reciprocal of -17 over 2, which just means we need to flip our denominator and our numerator. So this becomes -2 over 17. And now we have two fractions, so we just multiply across. And so 17 times 2 gives us 34. And then 4 times 17 just ends up giving us, oh my gosh, Why don't y'all tell me? This is just 7/4. And so 7 times 2 is 14. 4 times 17. If you don't know what that is off the top of your head, do the algorithm, but it's 68. And what we remember is that a negative times a positive is a negative. So that means our product is negative. And we can simplify. We see these both are even, so I can divide by 2. And so I end up getting negative 7 over 34. And then finally, we go to part C, which is dividing decimals. And so what we end up doing is we end up dividing our decimal by, first off, creating our symbol. And so we end up getting our dividend is inside our division symbol, so that's a negative. And then our divisor is on the outside, that's negative 0 and 32 hundredths. But when we divide by decimals, we actually need to get it as a whole number. So if our divisor is a decimal, we see that this is in the hundredths place. So we multiply by 100, which means we multiply our dividend by 100. And so we move it over 2 decimal places. And so we multiply it by 100. And we rewrite this as 250 divided by 32. And so that's negative 32 and negative 250. But you know a negative times a negative divided by a negative is a positive. So we know our answer is going to be positive. As you guys remember, we should take our time by writing our multiples on the side. This is going to make this division go by quickly. 32 goes into 2 0 times. 32 goes into 25 0 times. But we can see 32 goes into 250. 1, 2, 3, 4, 5, 6, 7. 7 times. So we bring down our 224. And then we subtract. So we regroup. 10 minus 4 is 6. 4 minus 2 is 2. Now we have nothing to carry down, so we need to bring up our decimal and add a 0. 32 goes into 260. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. And so that's 224. Now we subtract. We need to regroup. 10 minus 4 is 6. 5 minus 2 is 3. We're just doing our algorithm. Now what we can see. Oh, whoa, I messed up. I keep messing up this video. It is 8, but it's 256, which means 256 minus 2. 260 minus 256 is just 4. So we keep adding our 0. 32 goes into 41 time. And so we keep subtracting. And we keep going. And so 32 goes into 82 times. That's 64. And so this means 80 minus 64 gives us 16. Add our 0. 32 goes in 160. 1, 2, 3, 4, 5. 5 times. And we end up getting our answer is 7 and 8,125 10,000ths. So this is actually positive 7 and 8,125 10,000ths. With that being said, I'm just going to go to E because we're actually running out of time. I don't want the direct instruction to go too long, and I'm already starting to mess up here, but I want to show you how to multiply decimals. And so what we want to make sure is the factor with the most digits goes on top. So that's 3 and 24 hundredths times negative 0 and 52 hundredths. So what we know is that a positive times a negative is a negative. So we know our answer is going to be negative. But first off, we can see that we have 1, 2, 2 decimal places, and then 1, 2, 2 more. That tells us that we're going to have to add in 4 decimal places in our product. And so we get 2 times 4, which is 8, 2 times 2, which is 4, 2 times 3, which is 6. Now we move over a place value to our tenths place. And to show that we're no longer in the hundredths place and that we move to the tenths place, we need to make sure to add in a placeholder. And so 5 times 4 is 20. We regroup our 2. 5 times 2 is 10. Plus 2 is 12. Regroup 1. 5 times 3 is 15. Plus 1 is 16. we add these together. And so that's 8 plus 0 is 8, 4 plus 0 is 4, 6 plus 2 is 8. Bring down our 16. Remember that this was a positive times a negative, which means our product is negative. But we also need to add in our 4 decimal places. So that's 1, 2, 3, 4. And so that means our answer is -1 and 6,848 10 thousandths.